Long before the snow melts, before the soil warms and the blue skies return, the seed of an idea is planted. Every grower knows the pull.
This is the year we'll grow juicier, better tasting tomatoes. This is the year we'll grow more lettuce with less water. This is the year I'll grow something brand new.
Every grower feels it. This is the year, a brand new opportunity to grow more, to do things better. And it starts with the seed. For moms, the pull is even stronger.
Can I provide even more nutritious food for my family? What new tastes could I introduce to them?
Like any grower, Jessie plans and puzzles over this year's planting, whether she's thinking about her family's garden or the trial fields at work. Because Jessie, the home gardener and mom, is also a plant breeder by day, producing new seed varieties for America's farmers. Her decisions as a plant breeder parallel what she's planning at home.
What would make this crop better? How could we get the same land to produce more?
Whether you're growing food for a family or for the world, you're following the same path. Better seeds lead to better life. Every grower knows the best results always come from the best seeds, with plenty of care and nurturing along the way. Seedlings grow into plants. Plants produce their food. The bounty begins. The fruits of Jessie's labor are clear. At home, the bushels of carrots, tomatoes, and cucumbers will provide nourishment for her family. And on the job, a healthy crop means a bountiful harvest for farmers and more nutritious and affordable food options for families at the grocery store.
This year was great. And maybe next year, I'll plant more peppers. Maybe try a new tomato. Maybe it's time for Kier and Kelsey to plant a patch of their own.
The seed of the idea is already forming. Next year will be even better. Better seed, better life.
If you're a grower like me, you always have the seed of an idea in your head. And our ideas will grow into environmentally sound solutions for a sustainable planet.
Good morning, everyone, and welcome back to the second and final day of ASTA's Plant Breeding Innovations Media Tour. That video you just saw was filmed with Jessie Alt, who is a real-life mom, home gardener, and plant breeder, more specifically wheat breeder, with Corteva Agrisciences, one of ASTA's member companies. We have a great agenda lined up for you today, so we'll get right to it. First this morning, we're going to hear from representatives of Bayer about a collaborative approach to breeding for growers and consumers using peppers as an example. Our speakers today are Dr. J.D. Rousseau, Head of Vegetable Research and Development, and Dr. Murad Ebendaber, Head of America's Vegetable Breeding and Testing. Just a reminder to please type your questions in the chat box throughout the program, and we'll bring our speakers in live to answer those after the presentations. So Dr. Rousseau and Ebendaber, I'll hand it over to you.
Hello everybody, I'm J.D. Rousseau. I'm the Senior Vice President and the Head of Global Vegetable R&D. I've been with Bayer Crop Scientists for about 22 years in various parts of our global business. I bring a passion for plant breeding and science to the way we actually innovate, disrupt and develop our products, but also solutions to our growers and customers just like you. I'm really excited about our global vegetable R&D design engine, and for a couple of reasons. The one is we truly have the most diverse global germplasm library in the world for our key crops. That allows us to do two things. First of all, it allows us to look for find solutions globally for local conditions. For example, disease resistance. We can actually leverage our global germplasm library to find solutions for what you need in the US or in North America, specific around disease. The second piece about our global germplasm library is the fact that we have the opportunity to continuously innovate and find new solutions for current and future challenges that our customers, US growers might face. For example, labor shortage, climate shift and changes, or new farming practices. We have global collaborative breeding pipelines set up for our key crops around the world. This creates the opportunity for us to breed global but then deploy local based on the local conditions that our products need needs to fit to provide solutions to our customers, US growers. We test our products in about 31 countries just for peppers around the world. We have the opportunity then to deploy about 20 plus new varieties every single year around the world in our pepper portfolio. And that allows us then to have a robust commercial portfolio across 100 plus countries of about 300 varieties. For our different crops, we have a global trialing or field testing footprint, which allows us to use data from around the world to be able to make better decisions within our breeding pipelines by our breeders and scientists. For example, we test our peppers at 31 countries around the world. We have about 1,000 plus unique testing locations where we generate data. And then also we're working on a high throughput phenotyping platform to deliver new data and insight for images and sensors based on our products in the field, and using that data with our plant breeders and scientists to make those recommendations on what to advance and how to position them with our growers. So a grower in the Southeast US can benefit from our global testing by the ability that our breeders have to bring the data together from around the world to better position the product in his or her farm in the Southeast US. We have a new product design center in San Nicolas, Spain that we developed for the purpose of generating new varieties and inbreds much faster through the use of advanced technologies. This facility that just got operational the end of 2020 allows us now to bring products to market at least 1 to 2 years earlier. In pepper specific, it allows us, our US programs, to again bring products to life quicker for our US commercial growers. We are very uniquely positioned to have the most aggressive and broadest screening of diseases for peppers around the world. We test about 15 different diseases and pests in our field testing operation lab facilities to address the needs of growers. We also have about 20 different traits in our commercial portfolio and in our pre-commercial portfolio specifically for pepper globally.
Hi, my name is Murad Abdelnader. I'm the head of breeding and testing in Veg R&D.
My name is Tyler Eckert, and I am the head of America's Soil Nation Breeding at Bayer Crop Science.
Breeding pepper focus on different traits. Of course, yield is always a key component, but we also focus in our breeding effort on the taste. For hot pepper, pungency is very important. The heat of the pepper is important. We see that the consumer is becoming more global, but every geography has a different appreciation for the taste. So we focus on that consumer aspect for the product that we bring into the market. Likewise, color, shape, for the firmness of the crop is important. Another aspect that we look at is the holding capacity of the feed and the synchronization of maturity, which allows us for more automation of harvest, which is something that the processor in particular are asking for. We start our breeding effort by creating parental lines, and there we bring germplasm, the different germplasm together. We leverage our genotyping platform to drive trait integration, traits such as disease resistance, so we bring them into that parental line.
As the needs of growers and consumers change, it is critical that our breeding programs are able to rapidly adapt to meet those needs with new and improved pepper varieties. At Bayer, we are implementing cutting-edge technologies to deliver better products to our customers at a rate faster than ever before. As an example, consumer preference for jalapenos has shifted towards varieties that are smooth and non-cracking. In order to bring these new varieties to our growers and consumers as quickly as possible, we leverage double haploid and genomic selection. Using double haploids, we are able to develop inbred lines from new breeding crosses without the multiple years of selfing it would take to go through conventional breeding. Then with genomic selection, we leverage genomic data on the new double haploid lines to predict which lines will produce hybrids without fruit cracking before we ever see the plants in the field. This way we can get the right genetics into our pipeline as quickly as possible to meet grower and consumer demands.
Hybrid assessment and testing is very important. We test in different environments. We try to test in the environment where the growers are growing our hybrids and products. We also try to leverage environmental data to make sure that we understand the interaction between the germplasm and the environment. And most recently, the data is also leveraged to understand how we can manage the crop better. So there is the germplasm, its interaction with the environment, but there's also the interaction with the cropping and the management system that the growers are using. So all of this is really facilitated by the amount of data that we generate either in our breeding nurseries or in the testing footprint that we have across different mega environments.
Here at Bayer, we are committed to developing products that provide solutions for growers, customers, and consumers. Our products are characterized by high productivity, fruit quality, adaptability to biotic and abiotic stresses. For example, bacterial leaf spot is a major challenge faced by pepper growers across the Americas. Through our customer focus and innovation, our breeding teams at Bayer were able to be the first to develop and provide pepper hybrids with X10R resistance, providing resistance to all races of the pathogen. And we do this while improving yield and quality for our growers and consumers. In addition to ensuring our products hold up in the field, it is also critical that we understand the palates and preferences of our consumers so that we can provide desirable products to the dinner table. We have teams focused on understanding consumer preference and characterizing the composition and flavor of our products. For example, our hot pepper program must provide quality traits to meet a broad spectrum of consumer preferences. And our teams exhaustively characterize and select for the desired pungency level, shape, size, and taste to meet each specific market's demands.
So first of all, our breeding starts by defining the product concept, and that product concept is driven by what do the growers or the shippers, the packer need from this product. So we understand the attributes that we bring in our product. Sustainability is a very important factor of all what we do. We try to bring a hybrid that withstand diseases or withstand the lack of water and fertilizer, or that can valorize better water and fertilizers. We also focus on the quality. The growers, sometimes they are approaching market where quality attributes are more important than yield. So in our breeding effort, we focus on bringing high yielding hybrid, but also with high quality that meet the customer and the consumer demands.
My name is Luther Carson, and for the past 6 years, I've been a technology development representative for Syngenta vegetable seeds. As a technology development representative, I take new hybrids from breeding and research each year, and I trial them directly with my growers in my region to test the hybrids under their conditions. We place trials with growers because there's no better place to trial a hybrid than in the location where it's going to be grown. And when we partner with growers, we want to get them to the field to see the new hybrids and talk about them, and we use those thoughts in our advancement decisions. It's important to have relationships with these growers because I want our products to meet their needs so that they can be successful for years to come. One thing I'm excited about in our pepper program are the robust disease packages that we can provide, especially in a crop like red bell peppers where they have to sit in the field for a while, and we can stack in nematode resistance and powdery mildew resistance.
So one of the things that make any R&D organization successful, including ours, is the fact that we have a very diverse, innovative, passionate and experienced R&D organization. And that covers people that are plant breeders, data scientists, sensory scientists, pathologists, engineers and agronomists. These folks around the world help us deliver our products with passion to our growers and find those local solutions.
I'm happy to talk with two members of Bayer Vegetable Seeds' Consumer R&D Department, Dr. Martin Rubelt, our global lead, and Dr. Xiaoming Li, our sensory scientist. These researchers can help us understand the importance of keeping consumers top of mind as we develop new pepper varieties. Martin, please share some insights from the perspective of consumers.
There's several important consumer trends. Two stand out. The consumer wants to know where their produce is coming from and how it was produced. And the consumer is getting more demanding when it comes to quality of produce. That means better appearance, better taste and flavor profile, and also higher nutritional value. Especially during the pandemic, consumers are more concerned about eating healthy and what they can do to boost their immune system to stay healthy.
Well, what is Bayer doing to address these consumer trends?
Bayer develops differentiated products the consumer loves and enjoys eating. Consumers are looking for delicious and nutritious vegetables. Vegetables need also to be fun, colorful, and easy to be consumed. One of the fastest growing segments are snacking-sized vegetables, snacking tomatoes and snacking peppers. For example, our Just Sweet pointed peppers have an outstanding taste. My kids love to eat them when I bring them home from our trials. It's a myth that kids don't like vegetables. They just don't like bad tasting vegetables. Taste is in all consumer studies a #1 purchasing driver. Therefore, we spend a lot of effort to understand consumers' preference to ensure we develop pepper varieties the consumer really wants. Dr. Lee leads our global consumer sensory team and can elaborate on that.
Consumers are our #1 focus when it comes to developing better tasting varieties. You and I are consumers. We decide how much we like a product in microseconds. The amazing part is it all happens subconsciously. We use all our senses, vision, aroma, taste, texture, hearing, etc. Not only the decision is subconscious, it is also holistic. That means the brain combines all the feedback from the senses and form one judgment. Like it, or I want more of it. We test with consumers globally because we understand it is important to know the local preference. Different countries may differ in their preferences. A positive feature in one country may be a negative feature in another country, and vice versa.
Well, talk to us about peppers specifically. So can you give an example of pepper product development?
Some time ago, our breeder discovered a yellow pepper variety that has a unique shape, color, and taste. Well, because it is unlike a typical pepper variety, the team decided we needed consumers' feedback on this. We then conducted a large-scale consumer study in a geographical area of the selling region. The outcome was consumers love it. The yellow pointed pepper variety called Just Sweet is the perfect snack for consumers. Sweet, flavorful, juicy, and convenient. And more importantly, local. Subsequently, we launched the variety by working closer with the grower.
Martine, what about the importance of nutrition?
Vegetables are inherently healthy and nutritious, and pepper is certainly an excellent example for that. Peppers are low in calories and loaded with good nutrition. They are excellent sources of vitamin C, A, and E, potassium, folic acid, and fiber, to just mention a few. Enticing the consumer to eat more peppers and all the other vegetables will have a big impact on health and nutrition. Bayer Vegetable Seeds is perfectly positioned to advance health and nutrition by understanding consumers' preferences and deliver vegetable varieties the consumer really loves and desires. Remember, our vision is health for all, hunger for none. That's what we are striving for. Thank you.
Thanks so much for that great presentation. Doctors Rousseau and Abendauer, I'll have you up here to come and answer some questions. I see quite a few coming in.
Good morning, everybody. Thanks for inviting us this morning. Look forward to the conversation.
Yeah, thanks for being here. So while I'm gathering the questions, I had a question of my own to set the stage. So how quickly are you able to bring a product to market compared to 10 to 20 years ago? And what changes have you seen over that time?
Yeah, so maybe I can answer that question quickly. So the way that plant breeding is done across multiple crops, including peppers, is really to think about on working on processes and how we can speed up the product development cycle. So the way plant breeding works is we make up individual populations and crosses, and then we put it through an inbreeding process and a testing process over several years to test our products under the right grower environment or home gardener environment, and then we take products that we really properly test to market. And that process depends on the crop and the world region, take anything from 8 all the way to 15 years. So that the changes we've seen over the last few years is that breeding companies and plant breeders are working on reducing that timeline from product development process to the end product hitting the grower's commercial portfolio. The technologies that we've been working on the last few years within the plant breeding space is all geared to reducing that product development cycle in our plant breeding programs. And the reason for doing it is the ability for us then to quicker respond to market trends based on what the end consumer needs or what the home gardeners and growers need around product. For example, if there's a new breakout of a disease, we can respond much quicker by bringing in resistance. If there is a shift, for example, what Martin mentioned on snackable peppers, we can easily address that market need or gap or opportunity to bring products to life.
Great, thank you. So I have a lot of questions about taste and heat. So first of all, can you tell us more about how you select for heat in a pepper?
Sure, maybe I can take that. And lattering at what JD said, thank you for inviting us today. Really, we're happy to answer your questions. So, the selection for heat can be either based on, on the consumer panels. So consumer who are known to have a good taste for heat. So we use that. And most recently, we started using some analytical method to select for heat, and we have a scale for classifying our hybrid according to the level of pungency, which is a combination. It's a very complex trait, as a matter of fact. It includes spiciness, but also the heat. And it is a bit also subjective because, consumer in Mexico will have different appreciation from a consumer in the southeast of the US, or myself is from Tunisia. My appreciation for heat, what I call hot or spicy, is different from what a jalapenos pepper tastes in Mexico. So our method is to apply really both the analytical, the chemistry-based method, but also to continue relying on local consumer panel to assess the pungency and the appreciation of the consumer that are really regional to our hybrids.
Great. So, and going along with that, so you kind of spoke to it, that it seems to be regionally, there's preferences across regions, but do you see any general trends? Are consumers asking for hotter peppers than what is available today?
I think what's available today serves the need of a diverse consumer community. What we see is there is, because we move more, pre-COVID, of course, we used to move a lot, and you can see that the taste has evolved. I remember when I was living in Tunisia, as I said, and I traveled to Europe, I can notice that the European, they eat less hot pepper, for example, or spicy food. When I started, in the past years, I can notice that the European, for instance, they have more appreciation for that food because there are more, people who moved around the world. So we can see that demand for hot pepper and for that pungency is increasing in a way. There is more demand for that compared, at least my personal experience, compared to 10, 20 years ago. With that, we need to calibrate the hybrid that we are developing for the geography where there is a tolerance for a very spicy pepper, or for mildly spicy pepper. So if you look to in Asia, maybe the tolerance for the spiciness is higher compared to Europe or the Western Hemisphere.
Yeah, maybe just add, I think what consumers want is really choice, correct? If I look at my situation as well, I want choice, I want to experiment, I want to try new flavors, especially when you think about, as Murad mentioned, being part of a global community. And I think that variation and options we want to see right through the year in our kitchens, correct? So it's really, really important to focus on those trends, and there are a trend to get things more spicy and more potent.
And where do Seedless hot peppers rank on that heat scale? And are you working on peppers on the same range as something like a ghost pepper or a Carolina Reaper?
Yeah, I cannot tell you exactly where we stand compared to other, but I know that we tend to a diverse and a global, the demand. So if you look at our program in Asia, we rank pretty well compared to other hybrids in that region. Likewise, in Mexico, be it our jalapenos, anchos, serranos, we look at that punchiness and try to be tending to the different demands of the consumer community. In terms of developing new types, we are always looking at the market trend, the market demand, and trying to meet that expectation.
Great. So for those people who might not like the spicy peppers, in terms of sweet peppers, what are you looking for in terms of flavor?
Yeah, again, it's the sweetness. So, and of course, sweet pepper, the longer you leave it on the vine, the sweeter it becomes, correct? And the more vitamin C it brings. But we're looking at ways to bring that sweetness and that high vitamin C content, even if you harvest early, for example. Back to what Martin was saying, snacking pepper we see it as a very interesting segment. What we feel like probably is going to represent a new consumer trend, and we are very actively breeding to bring snacking pepper that is sweet, but also probably with less seeds, so that that experience is better for the consumer.
Maybe just the other component that we also focus on is the actual storability of peppers, correct? Making sure that from the point that the grower actually harvests it and we need to pack it and ship it, and when it gets to our kitchen, correct, the product actually maintains its freshness, etc. Because that's really important if you think about sustainability and food security and just food waste for us in the US, it becomes really, really important. Then again, if you step outside of the US into Africa and Asia and those regions, the shelf life and that durability of the product to stay fresh becomes really, really important from a food security more than a food waste perspective.
That's a good segue. I know you mentioned sustainability and food waste. So are there, can you expand on that a little bit about what you're doing in that space, and then any other new or novel traits for peppers that you're working on?
Yeah, so we focus quite a bit around sustainability. I mean, as a company and several of our competitors as well, there's been a big shift the last, I would say, 2 years to be much more responsible from a sustainability perspective. So the way that we try to do sustainability and how we actually embed it in our R&D group and our plant breeding programs in specific is in two ways, correct? There's how do we manage our operations, correct? We've got sites around the world. How do we make sure that those sites operates in a very sustainable way? We look at water, we look at lights, we look at electricity, energy, but also the carbon footprint of our operation. So that's one area we focus around. How do we just be good neighbors in the communities that we have research facilities in? The second piece is we've got a big focus around sustainability for smallholder farmers, bringing technologies to life for them, products that make sense. Again, that food waste component, but that's for those developing countries where we have smallholder farmers. And then the space that I'm really excited about that we started working on the last few years is how do we think different from developing, for example, pepper varieties if you put a sustainability lens on it. So again, it's shelf life, things like taste and flavor, bringing those components together, and actually how we think about designing and breeding these new varieties that can actually help ourselves, but also our customers and end consumers from a sustainability perspective.
Very good. Thanks.
Maybe to add to what JD is saying, there is the component of bringing, product that have longer shelf life, but we have also a great track record of creating product, and especially pepper, that are resistant to diseases, to pathogens, which leads to less usage of fossil fuel by the fact of the growers now needing less pesticides to bring healthy fruit to the market. So that's an important component. I will add, we are working on water and fertilizer efficiency, so pepper that can grow with less inputs. That's part of our pledge to using less fossil fuel. And last but not least, recently Bayer announced a carbon sequestration initiative, which covers all the facets of our business, where we want to really promote carbon credit when the farmer realizes that.
Great. Are you able to expand on that a little more?
Well, basically, the initiative has been announced, and it is on our website, bayer.com, and it talks about encouraging the growers and the farmers to adopt no-till or to adopt cover crop, and as they realize carbon credit, we will incentivize them for that.
Great.
And this is a pilot. It's a pilot that we are doing both in the U.S. and Brazil, but it will be expanded to other geographies as we realize the feasibility.
Great, thank you. So back a little bit to flavor here. Someone's asking, are you developing any low or very low heat peppers that retain the smoky citrus flavor of hot peppers?
Yeah, a great question. So again, it goes back to that consumer panels and to what is needed per region. So probably we're not working specifically on the citrus flavor, but that's something that probably I will ask the pepper breeder to consider, or to see what geographies are interested in that, and if there is a need, of course, we will address it.
Yeah, sounds like maybe some people are looking for that. And then other than flavor, what are some of the most important traits that you've seen consumers are asking for?
I think this.
Go ahead. Go ahead.
No, I think the big one is the shift to snackables, correct? So smaller peppers with different colors. Less seed or no seed, and then the crunchiness, and again the shelf life component. So those are the things that we're focusing on, and you need to make it fun, as somebody mentioned earlier. You need to make it fun and exciting for our kids to eat it as well, correct? I've got a middle schooler and a high schooler, and since I've been more involved with vegetables, that it's a different conversation, correct? And I think the produce that we have access to in our kitchens is just making it more fun, and we will continue on that trend as an industry to create exciting ways to help the nutritional value and the flavor and the taste of our vegetables as we go forward.
Excellent, great. I don't see any other questions right now in the chat, but we have a couple more minutes, probably time for one or two more if anyone thinks of anything. In the meantime, do either of you have anything to add that we haven't covered yet?
Yeah, maybe I'll just add that the one thing that we value really around the world is we've got these global breeding programs set up to think about our global germplasm collection and global trends. But then the way we actually parse it down is to make sure that we serve the local grower, because that's where the product needs to be produced, but also the local end consumer, as several folks mentioned, because they have unique requirements around what they prefer in the local cuisines, etc., and nutrition. So there is a big focus in that space. The other space that we get very passionate about is the nutritional space. So how do we actually think about nutrition in a different way? When you think about vegetables, can you combine this and link it to supplement around nutrition, correct? It becomes really an interesting space to really keep people healthy, especially now during COVID, and people paying more attention to what they consume.
Great, thank you.
Yeah, maybe to add to what JD was saying, we have a global collaborative team. So a lot of the pepper hybrid that we bring to our market here in the US and in Mexico, they either were developed in Europe or Asia, like the initial development, but then we find similarity in the environment and the demand from our customers, and we expand. And likewise, a lot of the other breeding effort that we do in the US also serves other geographies in Europe, Africa, and Asia. And really, the customers and the consumer are our focus. I mean, that's where we start our ideas and design our product. And as of late, as I mentioned, sustainability has become a big component of what we do in terms of advancing product that need less to grow.
Excellent. Well, thank you both very much. That about wraps up our time that we have. But if anyone does think of any other questions, feel free to email those to us and we will follow up afterwards. Thank you so much for your time and the great presentation and discussion.
Thank you.
We'll talk to you later. Okay.
Thank you.
So our next speakers are coming to us from Syngenta, and they're going to discuss how breeders leverage germplasm diversity for diverse markets. Joining us are Dean Lear, Regional Portfolio Manager for Watermelon for the Americas, and Rebecca Wendt-Naylor, Breeding Trial Specialist for Watermelon, Squash, and Melon. So I will hand it over to them for a recorded presentation, and then they will join us live for Q&A.
Growing populations and diminishing natural resources are just some of the challenges faced by growers today. As one of the richest sources of vitamins and minerals, producing healthy, tasty, and affordable vegetables in an environmentally friendly way has never been more important. At Syngenta Vegetable Seeds, we're committed to supporting the people who work tirelessly to feed the world, now and in the future. Our seeds have improved resistance and adaptability and bring longer shelf life, unrivaled quality, nutrition, and flavor. We're anticipating the changing needs of our world with 30 crop species and over 2,500 varieties. It's a commitment in every seed. Through close partnerships and local dialogue, we put growers at the heart of everything we do, developing solutions that address their unique challenges and needs. It's our dedication to unmatched quality and the expertise of our people that makes this possible. 2,300 employees in over 50 countries dedicated to the pursuit of best-in-class produce. At our world-leading R&D sites, trialing stations, and facilities across the globe, we work with farmers, academia, and environmental groups to unlock genuine value through innovation, bringing new varieties to market that address disease, changing climates, and evolving consumer demands. Every day, we're making a real-world difference, transforming how crops are grown and enabling growers to sustainably and responsibly make better use of resources.
I'm Dean Leary. I am the Regional Portfolio Manager for Syngenta for watermelons. First harvest was recorded over 5,000 years ago in Egypt and has since then grown to a worldwide dominant crop.
Hi, my name is Ivy Perez and I'm the Marketing Communications Lead for Syngenta Veg Seeds. Did you know early explorers used watermelon as canteens and that there are over 1,200 varieties of watermelon grown in over 96 countries worldwide?
Hi, I'm Rebecca Went-Naylor, a breeding trial specialist here with Syngenta. Did you know that the United States produces and consumes the most seedless watermelon in the world? And that Florida, Georgia, California, and Texas are the biggest producers.
A lot of people want to know, how do you pick a nice ripe watermelon? Well, I cheat. I'm in the field, I take a knife out and I cut them in half. When you're in the store, bottom line is you want something like this. We can see the rind, see the lines, how they're starting to differentiate. You'll hear people say, oh, the lines are breaking, the stop's breaking. You want that? If you flip it over, you want a little bit of a yellow spot if you can find it, but a lot of times you won't see that on watermelon. The other thing is pick it up out of the bin, hold it, get that nice sound, kind of a thud, not a ring. Perfect.
A lot of people ask us how seedless watermelons are created. They're actually created through a natural process that uses the plant's biology. So chromosomes contain all the genetic material that hold the traits for all living creatures. Plants and animals can have different numbers of the copies of their chromosomes. For instance, humans have 2 copies of their chromosomes, making us diploids. Potatoes are considered to be tetraploids because they have 4 sets of their chromosomes. Around 50 years ago, watermelon breeders discovered that they could cross a diploid watermelon with a tetraploid watermelon to produce a seedless watermelon. We take a male diploid flower and cross it to a female tetraploid flower and then grow that fruit to maturity. We can then harvest the seeds, which are considered to be triploids or having 3 sets of their chromosomes. Triploids are naturally sterile, so when we grow these seeds, they will produce a seedless watermelon plant that makes seedless watermelon fruit.
And Frankie gives a range of the types that you might see at the store when you go down and go shopping. I mean, there's everything from large size seedless. We have the small round seedless, which is very nice for the icebox. You can put it in the fridge. Seeded types, different colors, yellow flush, different rind patterns. Depending on the part of the world you're in, we'll have preference from some of the very dark green, what we call sugar baby types, the various types of stripes, to stuff you see in the U.S. We have something for everyone. And we're here today in our Naples Research Facility. Our Naples Research Facility is one site of many we have globally. We have actually 7 sites globally that we perform watermelon breeding at. In the United States, we have Naples, and in California, we have Woodland. Our focus and efforts being on the entire complete package, and that being disease resistance, quality, yield for the grower, a quality, desirable product for the consumer that brings them back for more. And we've been successful, starting with varieties like this, Fascination, and continuing on over the past 10 years. What I'm holding right now is a variety Fascination, which we first introduced approximately 8 years ago. This was helped start it all. Fascination is known for quality, disease resistance, yield. With that introduction, we followed up with Captivation, which we have down here in our trials a little bit further, and then Exclamation, trying to take off and build around the success of this variety Fascination. And most recently, we're coming out with varieties such as Sweet Dawn, which is behind me, which is a little bit different segment as far as maturity, being early, and a different genetic background, to the credit of Syngenta and our research programs. That's unlike what was several years ago. We have multiple backgrounds and genetic diversity that we're bringing into the market to further help provide a better adaptability, more variety differentiation, and something that will better fit the different growing regions within the watermelon production areas of the United States. In the case of Fascination, which you see in front of you, you'll notice immediately right off the bat the beautiful, gorgeous, dark red, deep color, nice flush contrast with the rind, beautiful quality, excellent shape, excellent rind appearance, and the right size for the consumer and the broker to take to the market. People will come back and ask for the variety by name. This variety is now considered a standard in the market that brokers, growers, and consumers are even now aware of and ask for.
I'm Matt Kincaid, watermelon breeder at Syngenta, and we're here at our Naples Research Facility looking at the newest seedless watermelon variety in our portfolio, Excursion. Excursion's key features are a strong vine, large percentage of 36 count watermelons with a full disease resistance package of Anthracnose race 1 and Fusarium race 1. Excursion shows high adaptability to most seedless watermelon growing regions, and the key strength of this variety is its ability to make size under difficult conditions. Excursion has demonstrated high yields comparable to well-known varieties such as Fascination, Captivation, and Exclamation, with a nice, classy rind that shows really well in the bin. On top of all of those things, Excursion has very nice fruit quality, firm flesh, and is 2 days earlier than Fascination after transplant. Excursion cuts really well, has great firmness, crispy texture, and small pips, and is an excellent entry into any grower's seedless watermelon growing program.
As a part of the breeding process, we're constantly producing new varieties. This is one of our newest varieties. It's called Powerhouse and was formerly known as WDL 7401. This new variety has anthracnose resistance as well as Fusarium wilt race 1. One of the reasons why we like this variety is that it produces really nice blocky fruit and it has a really thick rind, so that's great for shipping. One of the things that I really like about this variety is that it has really high sugar content as well as a really excellent flavor. This variety is now available through the Full Count program as plants and as seed. We've been trialing Powerhouse throughout the United States over the past 3 years, and it's broadly adapted to multiple geographies, particularly in Florida, Georgia, Indiana, and North Carolina.
We're at our Naples research facility looking at seedless watermelon variety Sweet Dawn. Sweet Dawn is the earliest maturing seedless watermelon variety in our portfolio. The key features of the variety are an attractive dark green striped rind, 74 days maturity after transplant, in other words, 5 to 7 days earlier than Melody, with 16 to 20 pound melon size. It also possesses intermediate resistance to Anthracnose race 1 and Fusarium race 1. The key feature of this variety, in addition to the maturity and the size, is the incredible dark red fruit quality. This variety is going to be a great tool for watermelon growers to hit the early market with size and quality. Other features include dense flesh. We see less hollow heart in Sweet Dawn compared to most varieties, and a nice crispy texture. It's an excellent addition to the watermelon portfolio, and it provides watermelon growers with a key tool, something that's truly early versus the main season varieties such as Fascination, Captivation, and Exclamation to round out their program.
Deliciosa, which you can tell from the name, this is designed for Mexico. It's done very well in Mexico. The unique item about Deliciosa, it's early, but you can tell it has a little bit of the darker stripe on it, what we call the darker crimson stripe that looks similar to Fascination. So a little bit richer rind color, a little bit more appealing to the consumer and to the buyers that you're selling to. It has been quite nice in color because it does that. Extremely dark red color, very nice, good quality, high flavor, very good appeal, pairs well with Fascination. Two other varieties we have for Brazil are Manchester and our latest one, Liverpool. Manchester has dominated the market in Brazil for years. Large size, seeded type Crimson Sweet round has done extremely well for several years. We have a new one called Liverpool. Liverpool basically takes the benefits and the value of Manchester and improves it. Bigger fruit, more yield, with the added benefit of powdery mildew tolerance. So you get the added benefit of powdery mildew with this over Manchester. You can tell fruit size has been big. We've had trials where our yield, we see a yield increase with Liverpool. So a lot of reason for the grower to grow Liverpool as the next variety that he can go and take to the market and deliver that, which is all quite amazing. Very firm, will take the transportation, large fruit, everything that both the grower and consumer desire.
Hi, I'm Rebecca Wint-Naylor, a breeding trial specialist with Syngenta. Plant breeding relies on naturally occurring plant diversity to produce new hybrids. Here you can see some of the genetic diversity that Syngenta uses to produce these new hybrids, including the flesh color, rind pattern, and then fruit size and shape. Syngenta draws on one of the largest germplasm pools in the industry, so we're very interested in conserving genetic diversity. Using genetic and statistical tools, we are able to speed the breeding process to bring new hybrids to the market faster. This results in higher yields for our growers, better sustainability for the environment, and better tasting fruit for our consumers.
Thanks for the great presentation. Dean and Rebecca, I'm going to have you come up and join for the Q&A.
Cool.
Good morning.
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 Good. As we're waiting for some questions to come in, I wanted to ask a question first. So obviously, Syngenta has put a lot of focus on developing the firmer and better tasting watermelons compared to some of the older varieties. How do you think that this research has benefited growers and consumers, and what do you see on the horizon for the future?
Good question, because what we did is that one picture you saw with all the different kinds of watermelons and stuff. We pull out of that background some of these different types of germplasm we get to play with. Because I have one of the best jobs in the world. I get to eat watermelon all day. And we've identified some backgrounds that are firmer. And besides being firmer, the bigger thing is they retain the liquid inside the cut product better. Because what we need to do is design something so when you and I go down to the store and want to buy watermelon that's already cubed up, ready to eat, get rid of all that liquid that's in that container. And we have material that does that. It's firmer, but the bigger thing has lower purge, so you don't see this flush of liquid coming out of it. Because we need to get something within that realm so we can increase consumption and get a more desirable product that people want to eat and enjoy watermelon even more than what they do today.
Great, thanks. So from a consumer's perspective, what are some benefits of seeded versus seedless watermelon?
You want that one, Rebecca?
Yeah, I can go for that one. I'd say that it really comes down to personal preference. Some people really just prefer a seedless watermelon over a seeded watermelon. And really, it's your choice there. But one of the advantages of eating the seeded watermelon is that there are some health benefits for eating the seeds. They're pretty high in good, healthy fats and also protein, as well as some vitamins and minerals. But overall, it just comes down to what do you prefer to eat, a seeded or a seedless?
Interesting. I did not know that about the seeds.
And what we've seen in the market is that there was a great shift to seedless probably in the early 80s in the U.S. markets. And you talk to some of the old-time growers, when that shift occurred, all of a sudden there was such a high demand on seedless, they could barely sell all the seeded watermelons they had. And now the market in the U.S. has shifted to over 90% seedless watermelons right now. There's a lot of seeded watermelons, don't take me wrong. There's still a lot of seeded that's used in home gardens and local roadside stands, which are great. But it was driven by the consumers and the retail trade, where basically you go to the store and the most things you see now are seedless. And when they're harvested and done properly, they're fabulous.
Great. How long does it take to develop a commercial hybrid?
See, this is the fun question, because if you ask a breeder this question, they go into this long ad nauseum talk about how it takes 27 years to develop germplasm and genetics. And that's really, sorry, don't buy that. The reality is we have a wealth of germplasm, and what I tell the breeders and people like Rebecca, because she's one of the key people involved, is that from the time the breeder makes that cross, and I look at it in his trials on station, that variety is either going to be dead in 2 years or we're going to be selling it by the 3rd year. That's it. Because if we identify something good, we need to bring it to market quickly. Otherwise, you're not a serious player.
Yeah, and to echo off of that, we'll look at it at our stations in Florida and Georgia, and then pick maybe 5 to 10 of the best varieties that we see in those locations. And then we trial those throughout the United States to see how they're going to perform. And from there, we might only pick maybe one variety and push that one onto commercial. But we do a lot of commercial testing just to make sure that it's going to perform well before we take it into the marketplace.
Because within the realm of doing that, part of the reason is, and we've been successful in doing that, is because we have probably, legal told me I can't tell you what % share we have, but I can tell you that probably 1 out of 2 watermelons that you eat come from Syngenta. So we are very, very successful in the market. We need to bring new items in the market, new innovation, and be quick about it. We have people like Rebecca, who's one of our best ones, who basically, when I go out and look at her trials, it's very simple. If it doesn't pass the test of Rebecca, I really don't care. I don't want to look at it anymore. And then we identify, we move, keep moving, bring in some new traits, new disease resistances, and we proceed.
Thank you. Let's see. Are you trying to breed more watermelons with shorter vines or earlier maturing for home gardens?
We've got a few that fit in that realm, because the trouble within the home garden or in a big field is that a grower is picking a specific area, and he needs yield and needs quality. Well, so how do you get more yield? We can get more yield a few ways. One is trying to get a shorter vine so you get more fruit in a given area, or try to make it a more viney plant to again get more fruit in a given area. There are some bush types if you look in the germplasm repository. There's some what they call bush types, but nobody's been really successful with those yet. So, but we've been trying. But for the home gardener, there's some pretty good seeded varieties out there that if I was a home gardener, that's what I would start and work with, because they take up less room and a few other things that would be very good for a home gardener to try and have some good success.
Going along with that, any advice for home growers who want to grow seedless watermelon in their gardens?
Ooh, growing seedless is a pain. I mean, I gotta be honest with you, it's a pain. And the first thing they need to do before they try to get seedless is make sure you can grow. If you can grow a seeded watermelon first, then worry about it. And to do that in a home garden, watermelons take up a little bit of room. You need some room for it. They like heat. They like a lot of sun. They like a relatively well-drained soil. So the way you do that is you cheat. If I was a home gardener and I wanted to plant one in the backyard, what I do is I make myself a nice little mound of dirt. I probably go down to like Home Depot and get some real soil versus the crap I'm farming. Work it in, put a little compost, make a nice little raised area, maybe a little small raised bed. There's some seeded types. You go on the websites. I would start with, there's a variety we have that's been around a while called Quetzalli. It's spelled Quetzali. And you can find that in some various of the home garden catalogs and areas. It's relatively early, kind of a medium-sized, small seeded type. There's actually, to even be better about it, because instead of believing me, you can go on to, there's what they call the All America Selection website, the AAS group, which is a third-party company that looks at and evaluates varieties throughout the U.S. that you can go and look on and see which ones have done well. Select one of those. There was one, in fact, I went back and looked. I used to be an All-American judge. It was kind of fun. Then I had to do real work. And there's a variety from years gone by there's one called Sweet Beauty. If you go on their website, I think that was one of the ones I picked years ago, or helped pick. But they have a list. Start with the seeded, because if you're successful with seeded, then you go to seedless. So start with that, then go to seedless.
And to echo off what Dean was saying, I would strongly recommend that you check with your county extension agent. They can help you figure out the right timing to go in. We're planting watermelons in Florida right now, and in most places in the country, you wouldn't want to be planting watermelons. So you kind of need to really think about that timing, and it generally takes about 70 to 90 days after transplant to produce a ripe fruit. So you have to keep in mind there's a lot of insects and fungi, a lot of things that can go wrong in that process, and your county extension agent can definitely help you there.
Great, thanks. Okay, so most stores only carry 1 or 2 watermelon varieties. And if you wanted to sample many varieties, is there a retail option for a homeowner?
No, not really. And the thing is, you think they're only carrying 1 or 2 varieties, but the reality is a lot of varieties look the same when you go to the store. There's probably, we commercially sell, probably the bulk of our sales is probably 7 different varieties. I'm not sure if I was a homeowner, I could tell that when I went to the store. The best thing you could do, to be honest with you, is probably go to one of the local farmers markets, and where they might have a little bit more of a range of types and selection, or some of the roadside gardeners, and select and try a few from them to get a better idea. Like I say, we have one. We have one, like I say, it's an older variety. It's called Quetzalli. Quetzalli is the bird of Central South America. It's Quetzali. It's a nice little. The breeder who developed that was one of our first successful breeders by the name of Tom Williams. He's also the guy that developed a variety called Sangria, which is still recognized in the market as a high-flavored, very successful seeded variety.
Excellent. Okay, thanks. Let's see. How has the changing climate impacted watermelons in recent years, if you have seen that happen, and what are you doing to address those changing conditions?
Yeah, I can take that one. So with climate change, we're already seeing a lot of fluctuations in temperatures and weather patterns, as well as some increases in extreme weather events. So to combat this variability, we're really trying to select the most resilient new varieties that are widely adapted and can withstand adverse weather conditions better than their predecessors. And we do this by testing our new experimental hybrids
with their current commercial growers throughout the United States. And then we select the plants that perform well under these real-life grower conditions and drop any hybrids that don't have consistent performance. And a good example of this would be our watermelon variety called Excursion. I've seen this produce fruit in some of the worst environmental conditions, from South Florida to Indiana to California. It's really widely adapted and honestly seems to flourish, especially when it takes a beating.
Okay, thank you. Okay, we have another question. Can you talk about the distribution supply chain model for watermelons in North America or globally? And how are your seeds eventually getting to full-grown watermelon in a retail store?
Sure, we can talk about that. Basically, with all of our watermelon seed, whether seedless or seeded, they're basically all hand-pollinated hybrids. So by and large, that's all being produced primarily in one of several different foreign countries we work with, because we need a lot of labor to perform this operation. We get the seed back to the U.S. We test it thoroughly for disease and uniformity. We have two basic models. We have a system of dealers that we sell through, who then sell to a lot of the bigger growers. Whether it be some of the big dealers in the East, Clifton Seed, Seedway, Rups, Rispens, right down the list. They sell our products, number one. Number two, we actually sell transplants. We sell because all seedless watermelon are eventually transplanted, and making transplants from seedless watermelon is kind of a pain. So we offer that. For the home gardener, we sell through our group in Syngenta Flowers, who sells to a lot of the home garden network and smaller retail stores and so on. And you'll see a lot of our varieties being offered within that. That's where you get out to, like, say, when I was checking on the Kitsilea thing, Southern Exposure Seed Exchange, Fedco Seeds, TNT Seeds, David's Garden Seeds. You'll see our varieties also offered through them.
Excellent. Well, thanks, Dean and Rebecca. I don't see any other questions at this time. We have a couple more minutes in case there's any last minute comments that you'd like to make. Otherwise, if we did not get to your question or you think of something later, please feel free to continue putting those in the chat box or send them to us via email, and we'll follow up after. So Dean and Rebecca, any final words?
Yes, I got one more thing for all you. If you haven't found it, there's a website called watermelon.org. And if you go to that, it's basically by the National Watermelon Promotion Board, which is one of the commodity groups, but they have a huge amount of information on watermelon health, nutrition, recipes, local events. I mean, watermelon is one of the most healthiest products there is out there. It's got a high amount of lycopene. It's nutrient dense, hydration abilities, a lot of good things about it. In fact, actually, watermelon has more lycopene than tomato because it's bioavailable to the body. In tomato, you have to cook it. With watermelon, all you got to do is eat it. And it's a great, fun crop, most exciting. But again, watermelon.org. So go check that out.
Thanks. Good resource. Okay, Rebecca, anything from you?
Yeah, I just wanted to say thank you all for inviting us today. And, we're really happy to share our goals. And really our main goal is just to produce genetic solutions for our growers, consumers, really all of our stakeholders along the line. So we're really excited to hear any feedback that you all have, and thank you for having us.
Thank you so much. I know I definitely learned some new things about watermelon. All right, we'll see you soon.
Excellent. Thanks. Thank you.
Okay. So switching gears a little bit, for those of you who are in the Florida area, or for anyone who is familiar with the citrus industry at all, you're no doubt aware of the devastating impacts of citrus greening disease. So before we head into our last speaker, who's one of the leading experts in this field, I'm going to show you a brief video to give you some context about the challenges that this threat is posing, and more importantly, some of the potential solutions that are out there thanks to plant breeding. So I will we'll tee up the video, and then we'll head into our final speaker.
A tree-killing bacteria is wiping out the state's famous orange groves. 90% orange.
I'm Fred Gamitter. I'm a citrus breeder and geneticist. I work at the University of Florida Citrus Research and Education Center in Lake Alfred, Florida.
In the heart of citrus country, with what scientists are doing to stop the disease.
Agriculture, and I think all humanity as a result, faces some real serious challenges going forward. But there are some new technologies, such as genome editing, using CRISPR, for example, that allow us to attack some very specific targets, some very specific traits that are going to be important for the sustainable production of food into the future. Citrus greening is, for the citrus industry, the worst possible nightmare imaginable. It's a devastating disease. In Florida, for example, our production in the last 12 to 15 years has decreased by 75 to 80%. This disease is caused by a bacteria that lives within the plant, not on the plant. So there's not any way to spray any chemical to kill the bacteria. It's in the plant. It's moved by an insect that flies and feeds on the plant. So it spreads fairly rapidly. When a tree becomes infected, you begin to see some changes in the leaves. As the disease progresses, the tree declines. You see dieback. It produces fruit that are misshapen, that never become very delicious. They don't develop the normal color, the normal flavor. Everything has changed. And eventually, the trees decline to the point where they're just not productive anymore. And it's spreading throughout the world. It's moved throughout South America, throughout Central America. It's been in Asia, in China, and India for more than 100 years. If we don't do something to solve the citrus greening problem, the decline in production is going to continue. Already many family farms in Florida have gone out of business. There are some packing houses for the fresh fruit industry that have been owned by families for 3 or 4 generations that have closed. But that way of life has supported 60, 70, 80,000 jobs in the state of Florida. So it's not just a handful of people who are suffering, but all the many people who work in businesses associated with this industry will be losing their jobs. We're on the cusp of seeing incredible breakthroughs using CRISPR genome editing methods to cure debilitating diseases in humans and animals. And we have the potential to do the same thing and more with plants. Basically, what we're doing in this case is going into the DNA code, the sequence of the plants, and making very minor changes to the letters of the words in the DNA code. So the idea here is that these are changes that are not drastic. It's simply working with the plant's own genome and making a small change. We're doing what it could normally do. Given enough time, citrus trees would develop resistance. They would evolve resistance to citrus greening. It might take hundreds of thousands of years. But if we can identify the gene that would make that difference, where that mutation could naturally occur, and do it now, we've accomplished something very important.
Joining us to wrap up our program today and to give us his expert insight into the future of plant breeding is Dr. Fred Gmitter, who you just met in the video. Dr. Gmitter is a research foundation professor in citrus genetics at the University of Florida. Fred, I will turn it over to you. And Fred, if you want to share your slides, or we can pull them up from our end. Yep. I think that you're muted. Can you hear us, Fred? You're muted.
Okay, there we go.
Okay.
Sorry about that. I had some last-minute internet issues, and I've changed rooms, hopefully for the better.
No worries. Are you able to share your slides, or should we pull them up from our end?
Let's try that right now. Let's see if we can do this.
Looks like it's working. Okay, great.
Okay, we're all ready. So First, thank you very much for the opportunity to be here virtually today. Yet another Zoom meeting in Zoom land. You have, I think, had the opportunity to hear over the last 2 days an awful lot of information about plant breeding techniques. So I think probably all of the people listening could probably take an exam right now and describe how to create triploids or define BLUP and so on. Let's talk about gene editing and the future of plant breeding. And I should confess up front that I am a plant breeder. I work on citrus. So my personal bias is in incorporating new techniques, new technologies into contemporary plant breeding schemes. Okay, looks like you have control of my slides. Sorry, can we go to the next slide? There we go. So what I hope to speak about today, to cover in the few minutes I have together with you, is a very quick review of the science of breeding, to talk about GMOs, and talk about this concept of gene editing or genome editing. This is most frequently done with a system referred to as CRISPR, and we'll talk about CRISPR, what it is, how it works, mention some of the applications of CRISPR in plant improvement. You've seen the video about the disastrous impact of Huanglongbing, HLB, citrus greening disease in Florida. We'll talk about some ideas about how CRISPR might be able to save our industry by creating resistant types. And then talk about some of the other possibilities that this new technology opens up to us and provide perspective on the future. So next, please. What is behind GMO, genetic engineering? In very simple terms, a gene is a piece of DNA that encodes a biological function. It's the sequence of the 4 letters, the 4 nucleotides of the gene, and how they're organized that determine its function. And in plant genetic engineering, we modify the genome of plants to achieve desirable changes in traits. If we're talking about what we might consider now to be traditional GMO technology, we're actually inserting another gene from another organism into the genome of the plant with which we're working. Next, please. So GMO, genetically modified organism, contains foreign genes, genes that do not ordinarily exist in the plant in which we're working. It can come from any other organism. It can be derived synthetically, but it's something foreign to the DNA of the plant. It's all based on historical discoveries of the DNA double helix in the 1950s and our ability to use recombinant DNA technology that developed in the 1970s. Currently, GMOs are very widespread in the world. GMO bacteria, GMO fungi, plants, and animals are used in research and in industry. GMO food is being accepted by the public slowly. In some parts of the world, very quickly. In other parts, there's an awful lot of resistance to it. Next. So let's compare GMO versus traditional plant breeding. The cartoons on the upper part of this slide give an example of what happens when we make crosses, whether we do this in watermelons or peppers or citrus. There's a gene that exists in a donor variety, and it's a gene that's important to fix a problem in the recipient variety. And so we make the cross, and in so doing, those strings of marbles there are randomly mixed and assorted, and we can select the plant that has the new gene of interest. But when we do this, we also bring a lot of other genes and alleles with it. So we're not just introducing the one characteristic or the one trait, we're actually modifying multiple traits of the plant. If we look at genetic engineering, we can take that one simple desired gene, and that can come from another plant, it can come from a fish, it can come from any organism, and we insert that into the recipient variety. And so now we've just modified the original genome of the plant that we had with one new gene that confers a new trait, a new characteristic. Next, please. So in history, the first GMO crop was a tomato that was put up for sale commercially in 1994. It was a disaster, not because the technology wasn't working, but because they used a really poor quality tomato to do the transformation. The tomato wasn't good even before the GMO modification. Since that time, though, we've learned an awful lot, and there are now GMOs of many, many stable crops such as corn, cotton, soybean, canola, and the list goes on, papayas, zucchini, squash. The release and planting of GMO crops over the last 20 years has increased quite rapidly. Next, please. GMO crops are grown in all of the nations that you see here colored in tan. It's quite a bit of the civilized world, the developed world, we should say. However, if you look in many of the other developing countries, or you look into Europe, which is certainly a developed region, you'll see that GMOs are not widely embraced. There are many reasons why this is, and I'm not going to get into any of those here today. But the fact of the matter is GMOs are not embraced by all humanity. Next, please. This is a screenshot of someone who was talking about the problem of citrus greening and how GMOs may come to the rescue. There's been a lot of work done, actually, to create GMO citrus that can resist HLB. But you can see this particular website doesn't really think so. And if you read the bottom line there, it's in small print. It says, so where are they getting these donors? Well, other kinds of trees, a couple of vegetables, a virus, and wait for it, pigs. And so there's all of this negative public perception that continues to persist. So GMOs, while they may work for us, perhaps we need another way to accomplish this. Next, please. All right. In this slide, the upper panel shows GMOs. And if that's not an option, what else do we have? Well, we look down below and we have traditional crossbreeding, which has been the way that humanity has improved crops for millennia. There is mutagenesis, and mutagenesis is a natural process that occurs in all living things. It can also be induced by treating plants with radiation, for example, to cause certain changes in the phenotype of those plants. And our third option is gene editing, and that's where we're going to talk today. The word CRISPR has been widely circulated. No, we're good on CRISPR, please. Yeah, widely circulated in the public media. Everyone has heard of CRISPR. People have heard of CRISPR being used to modify the human germline, so it becomes a very contentious, challenging technology in some sense from the PR point of view. But CRISPR at its best is really nothing more than taking advantage of some natural chemistry that can induce a mutation in a plant that is not any different from a mutation that might naturally occur given enough time and enough selection pressure. Next, please. CRISPR seems new, but it was first reported in 1987, at least the phenomena of bacteria producing enzymes to digest incoming virus attackers. It wasn't named until 15 years later in 2002 as CRISPR. Its role in immunity was defined in 2005. We learned about some of the different kinds of enzymes that can be used. The most common one used is Cas9, which cleaves, which cuts the DNA molecule. In 2012, we learned how to target that Cas9 to very specific regions of the genome. And this is the key to the use of this technology. We're targeting something very, very specific. In 2013, the first reports of Cas9 editing in eukaryotic cells, including plants, came out. And in 2014, actually, the first paper was published on the use of CRISPR in citrus. Proof of concept that we could go into the citrus genome and edit genes. Next, please. So let's consider CRISPR first. How do we make GMO plants? Let's go back a little bit. We make bullets of foreign DNA, and this can include these foreign genes or CRISPR, which in fact also is a foreign gene. We prepare the host so that they can absorb these foreign DNAs, and this is done in plants using agrobacterium transformation or biolistics, actually shooting small particles coated with the foreign DNAs into cells, or directly by protoplast uptake, by removing the cell walls of plant cells, enabling the foreign DNA to be taken up and incorporated. And that's followed, of course, by plant regeneration. We have to be able to regenerate from these cells that have been modified a whole plant. What is CRISPR? Well, it's clustered regularly interspaced short palindromic repeats, of course. CRISPR is actually a piece of bacterial DNA that contains short repetitive sequences. And as I mentioned before, the bacteria use this as a defense mechanism to digest, to chop up invading viruses. And we've learned that we can make this work in plants to make small changes at most places in the genome. Next, please. So, what's required? First of all, we need a guide RNA. This is an RNA sequence that is complementary to a DNA sequence at the gene at which we wish to make modifications. So this RNA is capable of being introduced into the cell, and it finds the complementary sequence on the DNA and it attaches. However, we also attach this Cas9 protein to the guide RNA, which you can see in the second panel there. And so we're now not only guiding the RNA to that spot, but that RNA has the enzyme that's capable next of clipping the DNA, actually making a double-stranded break. And then the repair process is how things become changed. We can insert foreign DNA, external DNA. We can knock out a handful of the nucleotides in that region so that that gene, when it's transcribed, is no longer functional. Next, please. So there are many huge advantages of CRISPR. It's easy to design a change to almost any single gene in any genome, provided, of course, that we have the proper sequence of that gene so we can make the appropriate guide RNA molecule to find it in that nucleus. We also have the possibility of changing multiple genes. Many of the plant genes of interest that breeders manipulate actually are members of multi-gene families, and it may be necessary not only to attack one gene, but perhaps multiple members of the same family, or other genes that are related to the same trait and characteristic that we want to use. It's very precise. We have the option, if we do this properly, to leave no fingerprint behind after making the changes. And by that I mean, I've mentioned that this is actually inserting foreign DNA, but if we do it in such a way that we can excise that foreign DNA, leaving behind only the native plant DNA with the changes, it's a clean operation with no fingerprint remaining. And so far, the US government and some other governments in the world have decided that if these changes are very small, and if the machinery has been removed, that these plants will not be subject to the complicated regulation that's associated with GMOs, because there is really no introduction of foreign or bacterial DNA that's remaining as there is in GMO crops. Next, please. So this is a list of plants where CRISPR has been successfully used for creating herbicide resistance, disease resistance. Many of these are proof of concept examples. Next, please. Our favorite white mushrooms have been edited by CRISPR. You know, if you cut white mushrooms and you let them sit out on the counter too long, the cut surfaces will become brown. This is caused by a very simple enzymatic reaction by polyphenol oxidase. If we can turn off that gene that produces that enzyme in the mushroom, they won't turn brown. And in fact, this has been done, and you can see the headline says that these mushrooms have escaped US regulation. Actually, it's been a conscious decision not to regulate such changes because they are extremely small and in fact not much different than some mutation that could naturally occur given enough time. Next, please. Another example here of corn that's been edited. to modify the starch so it can be used for industrial purposes. Again, the plant has been modified. They can use the best hybrids that exist for producing these compounds for industrial use. They retain the genotype and the phenotype, except there's this one small change that makes it more suited. Next. I mentioned CRISPR has been proven to work in orange. The first paper was published by Dr. Nien Wang's lab at the CREC, University of Florida. And there's an awful lot of work going on these days globally to use this technology to solve citrus problems. Next, please. I mentioned earlier that it's very important to be able to remove the machinery after the changes have been made to the DNA. And there's a paper published here in 2018 where we devised a method for not only producing, but for very effectively screening these modified plants with all the transgenic machinery removed. Again, only the native DNA exists with the changes of just a very few nucleotides. Next, please. Like all things, there are challenges and limitations. When we try to do CRISPR work, we find that the transformation efficiency is much lower than the typical GMO plasmids that might be used. Plant genomes can be much more complicated. Some plants are polyploid, which means there are multiple copies of the gene of interest, and we may need to target multiple locations. Plant cells are surrounded by walls, and it makes it much more difficult to be able to insert the foreign DNA inside these cells. We have to optimize this protein Cas9 for function in plants. Remember, it was something that evolved within bacteria, and we need to make some changes so, in fact, it works more efficiently in plants. We want to minimize or eliminate all off-target effects caused by this enzyme cleaving DNA. Potentially, it can go to closely related genes and cause some changes there as well, which underlines the importance of having good genome sequence. For the business of getting HLB resistance, however, one of the greatest challenges is identifying what are the relevant targets for HLB resistance. And I'll speak to that in just a moment. All these limitations, however, this tool is enabling very precise, potentially unregulated changes to the citrus genome or any other plants, allowing trait-targeted modifications. Next, please. Next slide. This is a very complicated slide that I don't want to explain. I want you to look at it and realize this is very complicated because this is a map of all of the potential cellular, biochemical, and molecular interactions that would take place when that C. liberibacter, that's the bacterium that causes greening in the upper left-hand corner, when that interacts or enters into the citrus cell. A number of things are involved in the host pathogen interaction. It's not a very simple process, so it's not easy to identify a single gene that we can attack with this technology. Next, please. So researchers in Florida and California and really around the world have been targeting a number of different genes that we find from other studies that are potential targets for HLB resistance. It may very well be that we need to target more than one. In the history of plant breeding, single gene resistance to diseases almost always breaks down very quickly. So to have long-term durable resistance to this disease, it's very likely that we need to hit a number of different targets. Next, please. On the left-hand side, you can see a number of approaches for how we might be able to do some of this. We can, for example, use CRISPR to go in and change a resistance gene from one that's not so resistant to one that is very resistant. Alternatively, in the second line there, you can see a string of susceptibility genes. These are genes that interact with something from the pathogen that stimulates or causes the cascade of events that leads to the disease syndrome. If we can take out these receptors, the plant can't develop disease. We can go ahead and modify the promoter. We can modify structural parts of genes. So there are a number of different strategies now that we have in hand where we can use these molecular CRISPR scissors to go in, cut DNA, and make changes. Next, please. I mentioned earlier that what we're doing is really not much different than naturally occurring mutations. This is a classic example in citrus. The first grapefruit known to humankind was white-fleshed and had about 50 seeds per fruit. It was introduced into the US in 1823. If you go to the market today, however, you can buy these seedless, beautifully colored deep red grapefruit on the right-hand side. This is the result of a series of mutations that's taken place over the last, in this case, the last 150 years to get us to 1970. That red color is lycopene, the same pigment that you saw in those beautiful watermelons a few minutes ago. And lycopene is produced in the carotenoid biosynthetic pathway. It's an intermediate. There is an enzyme called lycopene cyclase that digests or changes lycopene into beta-carotene. What happened in grapefruit that made it go from white flesh to red is that lycopene cyclase no longer functions. A naturally occurring mutation. Now, potentially, we could take a white grapefruit and using CRISPR go in and debilitate the gene that produces the enzyme that causes this reaction. And we could, by CRISPR, produce a red grapefruit from a white in a very short period of time, certainly much less than 150 years. Next, please. So talking about grapefruit, there's an issue that's known as the grapefruit juice effect. And quite simply, this is the result of some chemicals that exist inside of grapefruit that are called furanocoumarins. The furanocoumarins interact with enzymes in the human gut that are involved with the metabolism of drugs that we take. Furanocoumarins knock out the function of our enzymes. So when we're taking statins or we're taking blood pressure medications, instead of the normal amount of metabolism that would take place, the metabolism is knocked out and the amount of drug that you actually find in the blood is much higher than in the absence of grapefruit juice, leading to potentially risky situations. What can we do about this? Next slide, please. This is a selection that we released. It's called UF 914. It's a grapefruit hybrid. It was made not by CRISPR, but by breeding. And it's very, very low in furanocoumarin while retaining all of the characteristics, the color, the flavor, and the aroma of grapefruit. Next slide, please. When we tested the furanocoumarin content of UF 914, there are 3 members of the furanocoumarin family listed here, paradiscan C, 6,7-DHB, and bergamotin. And we compared 914 with the Hudson grapefruit. We saw that the most bioactive of all of these furanocoumarins, paradiscan C, was not detected at all in 914. And if you look at the second and third most bioactive, you can see dramatic reductions in the amount of furanocoumarin. So potentially this is a variety that might avoid the grapefruit juice effect. Next, please. 914 originated as a triploid. You heard something about seedless watermelons. We performed the same sort of crosses, a diploid low acid pomelo crossed with pollen from a tetraploid ruby red. We used embryo rescue to recover the embryo that grew to be the tree that's known as UF 914. The cross was made in 2002, and we released the variety actually quite quickly in 2012, 10 years. Or potentially, had we had CRISPR technology in 2002, we might have been able to simply use it to go in and modify the gene or genes that are responsible for furanocoumarins in true grapefruit. Next, please. So I hope you can see that CRISPR is a very powerful tool, but it's a tool, it's not an end-all. Traditional breeding, likewise, is very powerful. And traditional breeding, we might now consider contemporary breeding because we have a lot of new technologies, new approaches, including genome selection, genome prediction, and so on, that modern plant breeders are using. CRISPR is most powerful when it's being used to influence a trait for which there is little or no genetic variation. So what happened with our 914? Well, we did some consumer surveys. We found consumers who loved grapefruit and hated grapefruit. We talked to them about the grapefruit juice effect and the potential of removing that from the grapefruit world. Both the lovers and haters of grapefruit were really interested in this possibility. But what surprised us was that the non-grapefruit consumers were very much surprised by the sweetness of UF 914. So not only was it lower in furanocoumarins, but it also had improved sweetness. The sugars were higher, the acidity was lower, and as a result, we came to realize that there were actually many other things that had been affected as the result of our crossing. So the point here is that for plant breeding, for cultivar development and improvement, most commonly breeders are not looking at a single target, as we are perhaps in the case of HLB resistance, but we're looking at multiple targets, multiple traits, multiple characteristics that all need to be folded into the decisions breeders make as we move forward to commercialize new cultivars. CRISPR doesn't replace breeding science, it's supportive of breeding science. Next, please. What do we need to use CRISPR successfully? First of all, we need to understand the genetic mechanisms that are underlying the trait of interest. We need to have genes that we can target. We need, and this is very critical, a high-quality genome sequence assembly, one that's fully annotated. CRISPR is only as good as the quality of the genome sequence that exists because we're reliant on highly accurate genome sequence to create the guide RNA that we need to get CRISPR machinery to the exact gene that we wish to target. That's critical. We need to have effective methods to introduce CRISPR into the machines and we need into the cells, and we need to be able to make plants. We need to have the ability to make homozygous mutations because many of the genes that we're attacking are heterozygous. And if we knock out one copy, the other copy still may function and we may not see the result we want to see. We need methods to create edits in multiple genes. Very importantly, again, we need the ability to remove all traces of the CRISPR machinery. And breeding programs globally are integrating this technology within their cultivar development programs. Success means that the end product contains only the host genome DNA, expressing a mutation that is no different than one that might occur naturally given enough time. Next, please. That's my last slide. I'll leave you a photo of some of the beautiful fruit genetic diversity within citrus. I thank you for your time and attention. I thank ASTA for the invitation to come and speak today. And I'm ready for whatever questions we may have. Thank you.
Sorry, I'm on mute. Thank you so much for the great presentation. We have some really good questions here in the chat, some about citrus greening and some about gene editing. So I think I'll just start off here. How close are we for finding a solution to citrus greening?
That's always the most difficult question. We learn a lot more every day that goes by. There are labs all around the world looking at different kinds of solutions for citrus greening. Very recently, there's been some talk about a peptide that's produced by a kind of citrus called microcitrus that seems to be able to kill the bacteria. It's being tested right now, and if this turns out to be reality, we may have a solution within the next 2 years. Researchers have been working with a number of these peptides over the past 15 years, however, and some of them that look good in the beginning eventually fail. So we don't know that that's the case. We will continue to look for genetic resistance to citrus greening. We have developed tolerant types. There are some citrus rootstocks that allow the trees to grow in a more healthy condition, even when infected with the bacteria. We have some cyan varieties that are also more tolerant of HLB, but we're really looking for these knockout punches, something that we can put into the plant that will make them immune to the disease. And once we find such genes, We have to validate, verify. And then, of course, there must come a period of time where we're going to test these trees in the field for a number of years, because citrus trees, unlike watermelon and pepper, are in the ground for decades, not for a couple of weeks. And so we need to have something that really is robust and long-term.
Thank you. So going along with that, how far in the future do you think it could be that you could have the option of using gene editing? And then just in general, how far away are we from commercialization? What are some of those challenges, that stand in the way?
Mm-hmm. I think it's very likely we're going to find a gene editing solution within the next 2 to 3 years. That sounds like a long time, but citrus trees are difficult to work with. It's a long process. The bottlenecks are, once we find something and we test it in the lab and then we test it in the greenhouse, again, we have to go to the field and do some long-term field testing to confirm that it's going to be durable, to confirm that we haven't created any other changes in the performance of the plant that might be deleterious. And assuming all that goes as quickly as possible, we then need to look at ramping up the supply of plant material, because we're not collecting citrus seeds and planting them in the field and seeing a tree in 6 weeks later, like we would with a vegetable crop. Citrus trees are propagated vegetatively. We need to increase the supply of budwoods. We need to have budwood source trees that are going to provide millions of buds to be placed in nurseries. And the nursery takes a year to grow the tree, and then that tree goes to the field and takes 2 years before it has fruit. So this is a long, long haul for us in the world of citrus.
Yeah, it sounds like we need all the tools that we can get. So how are you ensuring that products produced from gene editing are safe?
That's a very good question. One of the ways to ensure safety is to make absolutely certain that all of the GMO machinery has been removed, because these are some of the issues with GMO crop plants that are a concern. There are antibiotic resistance genes and so on. But in most cases, what we're doing with CRISPR is actually, we might say, even safer than typical traditional crossbreeding, because we're affecting one single gene, or a small handful, a small number of genes. All of the rest of the genome, all the rest of the genes in the plant are still being expressed in the normal fashion. If we make a cross between different kinds of peanuts, for example, we don't know. We're bringing in hundreds and hundreds of different alleles for different genes, and we don't ever actually go ahead and test those plants to see, are these plants actually safe? We don't even think about it, but potentially there could be allergens that we're not aware of. So, one of the beauties of this system is that, again, we're affecting a targeted single gene.
Thank you. Okay, some technical questions here. How successful have you been in identifying resistance genes within the citrus germplasm library? And is this typically just one gene or multiple genes?
We've been very successful in identifying a laundry list of several hundred genes. But a laundry list is just that. And so the challenge becomes, as I showed in the one slide, the complex interaction of the pathogen and the host cell. There are many, many things that take place, many things that occur. And so we've got to narrow down our laundry list. And we have done that over the years by different sorts of projects to validate whether or not some of the targets that we find are critical. I don't think there's going to be one single gene that's going to be the solution. I think we're going to have to look at multi-gene targets. Again, just looking at classical breeding for resistance to wheat rust or any of the other pathogens in any plant you want to name, we find a single gene for resistance, and the bacteria or the fungi or whatever the pathogen is, they're very good at mutating and getting around that resistance quite quickly. And so a single gene would not be a good strategy, especially for a woody perennial plant like a citrus tree.
Thank you. Okay, on the topic of climate change is a major concern right now. Could gene editing play a role on combating climate change? I think maybe if you could speak to, I would say combating and then also helping, mitigate the impacts, but also helping crops withstand changing temperatures.
Yeah, looking outside of citrus, sometimes I get stuck in my citrus world. Looking outside of citrus, there are already a number of projects, a number of papers that have been published, for example, where researchers have used CRISPR to go in and modify genes that are associated with stress tolerance in general. It could be high temperature tolerance, it could be drought tolerance, and many times drought and high temperature, these are controlled by very similar pathways. And so people are, in fact, looking at doing these kinds of things right now. There's been some work involved with looking at how we can sequester more carbon out of the atmosphere into the roots of plants. And so people are working on plants now that have the ability to sequester carbon into their roots at much higher rates and to grow deeper roots that would leave that carbon sequestered in the soil. So there are a lot of different ways that this technology is being used to address climate change.
Great, thank you. Do countries that don't allow GMOs instead allow CRISPR? That is CRISPR more widely accepted than GMOs? Are you able to speak to that?
Yes. The simple answer is yes, but it's not universal. Certain countries that have not embraced GMO technology are allowing CRISPR technology to go forward. They're importing products that have been modified by CRISPR. If we look at our friends across the Atlantic Ocean in the EU, however, the EU community has decided that CRISPR plants are no different than GMO plants. And so currently they're being regulated in the EU. There's a lot of pushback on that because the reality is a CRISPR edited plant is substantially different from a GMO plant. Yes, the reality is we use GMO technology to get CRISPR into the plant to make the modifications. But again, there are some very clever ways to excise that machinery. And in the whole plants, in the end, there's nothing left except the native DNA if we do this process properly. And those mutations, again, are not different than mutations that occur naturally all the time.
Thank you. You've stated that you need to remove the CRISPR machinery. Is this basically extra gene material? What happens if it is left in the cell?
The machinery is actually excised. There are a number of different ways people do this. In annual crops, for example, you can use CRISPR and you can go in and make the change in the nucleotide. And CRISPR is in there in a heterozygous condition, so you can self those plants. And 50% of the next generation will not have the machinery inside the cell. It will have the modified DNA, but not the machinery. We can't do that with citrus trees because we can't self citrus trees. So we have to have other approaches, and we have developed approaches that allow these changes to take place within the cells, and then as we regenerate the plants, that machinery is removed. It's no longer present, not only in the nucleus, it's not in the cells. It's gone, it's undetectable. You can't find it, it's because it's not there.
Thanks. Okay, well, I think we've gotten to the bottom of the questions, but people may be still typing. So while we're waiting to see if there are any more questions, I just want to ask you from your perspective, what do you see as some of the biggest challenges other than citrus greening? What are some of the biggest challenges that you're looking at over the next 5 or 10 years, and how are you working to solve those? What makes you excited about plant breeding right now?
Why do I still go to work every day? That's the question. Before we had citrus greening in Florida, we had a large number of problems that we were working through traditional breeding to get solutions. There are a lot of other diseases that have not gone away because of the presence of citrus greening. They've just been overshadowed. We've always been interested in improving the quality of citrus products. We want consumers, to look at a citrus fruit, to taste it and feel compelled to go back and get another one. We want citrus addicts. And there's an awful lot that we can do to improve the quality of fresh citrus fruit as well as the quality of the juice. And we're looking at all sorts of breeding approaches to do that. CRISPR is another tool we have in our toolbox to accomplish that.
Great, thanks. I wish we could all be in person with you and sampling some of the citrus right now, maybe next year. I do have another question that came in. Could gene editing completely replace the need for GMOs?
I seem to have lost my sound.
Oh, we can hear you. Oh, can you not hear me? Can you see the chat box? Okay, well, if we don't get Fred back, we are running towards the end of our program regardless. But I want to thank you all for being here. If Fred did not get to answer one of your questions, please feel free to continue typing those in the chat box. You can also email them to me, and I'll be happy to follow up with him and get any questions to you that he may not have had a chance to answer. But thanks for great questions and a great discussion. And we just really appreciate you joining us over these last 2 days. We hope you found it valuable, gained some new insight into plant breeding innovation and what's happening for our future. Please continue to use us as a resource and feel free to follow up with any questions or requests. We're always here to help. My contact information is here on the screen. So again, thank you for spending this time with us, and we look forward to staying in touch. Have a great rest of the day.